All right, so to do the first part here, 1 through 6, first thing we want to look at is, you remember Newton's first law. Right, an object at rest stays at rest. An object in motion will stay in motion unless acted on by an outside force. We've seen this in class. We've talked about the idea of inertia, that objects have a property that's intrinsic to them that gives them a ability to either stay at rest or stay in motion unless you have an outside force. So now let's bring this to bear on this worksheet. How does this work in the real world? So if we look at the first one, for example, it says our object is at rest. Its velocity is 0. So according to Newton's first law, in order for it to be at rest, the outside force or forces acting on it must be equal to 0. Okay, so when we look at Newton's first law, all forces must be equal to 0. That's the consequence of this law. So we look at a situation like number 1. Since the object is at rest, the forces acting on it must equal to 0. So if there's a force to the left of 15, there must be a force to the right of 15. Those must be equal and opposite, and we're left with that. Situation like this, number 3. Right? There's a downward force of 7. It's going to be an upward force then of 7. Right? If it's not moving in the y direction, in the x direction it's also not moving, so then this force here would be a 10 Newton force. So that's how you do 1 through 6. So what you have to do for part 2 is you have to take any force at an angle and break it up into its components, its x force and its y force, right? Like we did with vectors earlier. And then you need to write what the forces in the x direction equal. So for example, if we look at this point, right, and we'll always look at the center point as kind of our point of emphasis. On this point, there's a force in the x direction called F1x, and it must be equal to F2. They're the only two forces in the x direction. This object is not moving, so then F1x, or it says actually it's an equality, so they're saying all the forces have to equal, so then F1x must equal F2x. And then the only two forces in the y direction are this F1y and this F3. So you can break these up. For example, this F2 is going to have an F2x. Oops, I forgot the x, and an F2y. Right? You do that for the other vector at an angle, and then you can write equalities for the x and y direction for this. Alright, and then you do the same thing for 10 and 11. For 12 through 17, what are you going to do here? Well, they give you a situation. They tell you that it's at equilibrium, so that's a word that means all the forces are equal and opposite, and everything cancels out, so the object's not moving. So, for example, this F3, we know that it's going to have a force, so F3 in the x direction. It's also going to have an F3 in the y direction. So then I can tell that F3x must be equal to 30, since these are the only two x forces. So then this force is 30. F3y must be equal to 40. So now how do I find F3? Well, I've got two sides of the triangle. This is 30 newtons, this is 40 newtons. I can do trig, Pythagorean theorem even, and find what F3 is going to be. In this case, it's going to be equal to 50 newtons. So this is how you do activity 1.